Okay, so today we're going to continue on with scatter plots. The only thing that we're going to look at extra today is that R. So real quick, I want to explain what the R is and why we use it. So everybody flip to that back page real quick. Do y'all see right here it says the correlation coefficient is denoted by R. It's a measure of the strength of the linear equation or the linear relationship between two variables. So you know how sometimes there's no relationship at all? Like I said, y'all's height and your grade in my class. So if you were to try to put that in your calculator, the R would be so far away from 1. Make sense? Okay, so look at these graphs right here. This is a perfect 1. Why is this a perfect 1? Every single dot falls on a straight line. Make sense? It is a perfect linear situation. This right here is a strong relationship, but it's not a perfect relationship. Does that make sense to y'all? So this would have an R very close to 1 because the dots are very close to being a straight line. This would be an R that's really close to -1 because these dots would be close to making a straight line that goes down. But this R would be really close to 0 because there is a very weak or absolutely nothing going on in that graph. Does that make sense? So for example, if I had a relationship like this, is there something going on here? There is. It's moving what? Up. But they're kind of spread out. If I was to draw a trend line, they're not super close to the line. Does that make sense? So this would be a weak positive relationship. So do y'all understand what the R means? Yes or no? When R is near 1 or -1, the linear relationship is considered strong. When R is near 0, the linear relationship is considered weak. So that is the only thing that the R means. So I want to make sure you all go turn the R on in your calculator if we didn't do that yesterday. So go to your calculator. Do y'all remember where to go? Catalog. Right above 0, so you're going to hit second 0. You're then going to arrow down and just hold the down arrow down until you get to the D's because it's alphabetical order, and find diagnostic on. Make sure the arrow is pointing to diagnostic on. Did y'all find it? Hit enter, and it's not done until it says done, so hit enter again. And then if you ever want to turn it off, you just go to the catalog and go to diagnostic off, enter, enter. Make sense? Yes? So now when you go to stat, calc, those R's will show up, and we're only looking at that bottom R. So whatever data I have in my calculator from yesterday is a very strong relationship because this number is very close to what? 1. That means the dots would form pretty close of a linear situation. I had already had data in here. Everybody okay? Okay, so does everybody know what R means? I'm going to look at it again. This is a perfect 1 because every single dot falls on a straight line. This would be an R very close to 1 because they're very close to forming a straight line. Everybody good? All right, go to the front. We're just going to do a few examples because everything on this is what we learned yesterday. All right, number 1, the table below gives the number of hours spent studying for a science exam and their final grade. So do y'all think there's a relationship between how many hours somebody studies and their grade? Probably. Probably the more I study, the better my grade probably will be. Could there be exceptions? Yes. For example, I studied 5 hours, but I bubbled my Scantron in wrong, and I failed. That would be that weird random situation, okay? All right, it wants to know what is the equation for the line of best fit. So where am I going to go in my calculator for that? Stat. So let's go to stat. Can I only put in like 2 of these? No, I have to put them all in to get a line of best fit. Let's round to the hundredths place again. Okay, for the R, if I round to the hundredths place, it's 0.99. Yes? Okay, make sure you got what I got. Everybody good? So, what kind of correlation is this? It's strong. Why would it be considered strong? Because it's close to 1. And is this a positive relationship or a negative? Positive. You know that, number 1, because the slope is positive, and number 2, because the R is positive. This is a strong, positive correlation. Now it says you're going to use your equation to make a prediction. Predict the exam grade of a student who studies for 6 hours. Okay, so we got to realize, are we going to plug in for X? Or are we going to plug in for Y? Well, was hours on the X-axis or Y-axis? X, and this is hours, so I'm going to plug in for X. So I would do 6.09 times 6 plus 63.93. So somebody who studied for 6 hours is expected to make what kind of grade? About 100. I would hope, if they studied for 6 hours. Are we good? All right, let's do number 2. I'm going to let y'all do it on your own. And then we'll go through it. Did everybody get the equation correct? Good. Okay, did everybody get the R to be very, very close to 1? So you wrote that's a strong positive or negative? Because the R is positive and the slope is positive. So it's a strong positive relationship. All right, B, if a man has a shoe size of 10.5, what would be his predicted height? So think about this. Which one of these was the X? Okay, the shoe size was the? So what am I going to plug in 10.5 for? So now you solve that equation, yes? Okay, so what is the expected height? About 72 inches. And if you wanted to know how many feet they are, you divide by 12, and 72 divided by 12 is about, what? 6 feet. All right, flip to the back. Let's go look at number 5. This is called a scatter plot that already has a line of best fit drawn into it. Okay, they're comparing the hours worked for the dollars earned. How many dollars did Jim earn for working 5 hours? So you go to 5 hours, go up to the trend line, and how many dollars would he have earned? 48. Using your line of fit, predict how many dollars Jim will earn for working 10 hours. So go to 10 hours. You're going to go up to your trend line. And where are you at? 72. 72 what? Dollars. Good. Is the slope of your line of fit positive or negative? Because it's going up. According to the line of fit, when Jim's hours increase by 5, how much do his earnings increase? I'm going to say that again. According to the line of fit, that's this line. When Jim's hours increase by 5, so you're going from 0 to 5, how much do his earnings increase? About, say that again, Adon? About $24. How did you do that? Did everybody see that? So on the graph at 0, where is it at? On the graph at 5, where is it at? And 48 minus 24 is 24. So that's how he got that answer. Everybody good? All right. Now, this is where my 5th period class was stressing out yesterday, so I wanted to go over this. Here is a scatter plot. Which one of these answer choices has a correct line of fit for it? C. Because a lot of people were really stressing out about that yesterday, and I don't know why. Y'all actually did pretty good, but my 5th period and 7th period were like stressing out about drawing that line of fit. So do y'all see how this one doesn't follow the trend at all, and neither does that one? Okay, the last thing we're going to go over today, it's not actually on your assignment, but it is a TEK that we're supposed to teach. We're actually going to go over this more when we start reviewing for the EOC, but I kind of want to just explain to y'all the difference between correlation and causation. So everybody look up here. Correlation means there is a statistical association between variables. Causation means that a change in one variable directly causes a change in another. Read that to yourself again, and then we're going to answer the questions. Everybody had time to read it? Okay, look at number 1. I don't want you to say the answer. I want you to mark it, and then we'll talk about it. The number of snowy days and the number of hot chocolates sold at a ski resort. Would that be a correlation, or would it directly cause the other one? Okay, what do y'all think? Anybody brave enough to give me your opinion? So it will directly, no matter what, it will cause that. Or is it just related? So correlation means it's related. Causation means it will cause it no matter what. Okay? So it's actually just correlated. It's related. If it's snowy, people are probably going to want what? Yes, but will it make them get it? No. Okay, so that's kind of the difference. All right, let's look at number 2. The number of minutes a furnace runs and the temperature of the house increasing. Don't say it. Mark what you think. Do y'all know what a furnace is? Okay. All right, what do y'all think on this one? Causation. If I turn my furnace on, it is directly going to make my temperature in my house increase. Very good. The next one, the number of miles driven and the amount of gas used. Let everybody think. Let everybody think. The number of miles driven and the amount of gas used. All right, what do y'all think? So the more I drive, I might run out of gas. I'm going to run out of gas, right? So that is directly caused from driving. That is a causation. Number 4, the age of a child and the length of their hair. It's a trick question. None. Neither. This is that one, like, I want to know your height and your grade in my class. There's no relationship at all, right? Number 5, the number of cars on the highway during a holiday weekend and the number of traffic accidents. What do y'all think? Good. There's definitely a relationship, but it doesn't directly cause it. Last one, number 6, the number of minutes a person spends exercising and their body weight. What do you think? Correlation. They're definitely related, but it's not always going to directly cause that because genetics come in, right? Some people are just born and they're super, super little and they can't gain weight, and some people are born and they just are born with a bigger predisposition. Yes? But it can correlate. All right, I'm going to pass out your... Put your name, quick. Okay, let's look at 1 through 6. All you're going to write is if it's positive, negative, or none. Got it? Go to 7 through 12. Cross off where it says draw a line of fit. Like I said, 5th period and 7th period, we're totally freaking out, and it's really not that big of a deal. But you are going to do what? How do we write an equation? What do we use? Stat. So the first thing you have to do to use stat is make a table. Very good. So you're going to make a table, use stat, and what are we going to round to? Hundredths. Very good. Flip to the back. Number 13 and 14, make a scatter plot. Mark off, draw a line. I'm not trying to cause y'all have an anxiety attack here. Okay, then right N. So use stat. Then on 15 and 16, read the directions. It's very, very easy. And make sure you do every single thing it asks for, okay? Super easy. I hope y'all finished today. You should have plenty of time.